everybody. Today we are going to be taking a look at proportional relationships. So, proportional relationships represent a constant rate of change. So that means it is staying the same throughout the entire set. So constant means that it stays the same. The rate is the unit rate or the original amount for 1, and that will be changing by that amount. Two things will be true about a graph that is proportional. One, the graph will be a straight line. Two, the graph will pass through the origin, or 0, 0 on your graph. In a table, we want to check for equivalent ratios. In other words, a proportional table, the ratio of y divided by x will always be constant, or the same. So, it says, the number of miles a white-tailed deer travels is shown in the table below. Complete the missing information and answer the question below. Well, the only information that they gave me was in this table over here. Well, I gotta relate my y value to my x value to try to find a constant rate that the white-tailed deer traveled in miles per hour. Well, I know he went 84 miles in 3 hours, so I can take my y value. Remember, my constant formula is y divided by x, so I can take y, 84, and divide it by x, which is 3. 84 divided by 3. And when I do that, 84 divided by 3, I'm going to get a constant rate of 28. Now, the other information they gave in this table was that he went 196 miles in 7 hours. Well, if I want to find that constant rate, I can take 196 and divide it by 7. And again, I'm going to get an answer of 28. So I know that my constant rate for this deer is 28 miles per hour. Now, you could add 28 to the previous number. So if I took 28 plus 28, so I take 28 plus 28, 28 plus 28, I'm going to get an answer of 56 for 2 miles, because it's 28 for the first mile and 28 for the second mile, giving me a total of 56 miles in 2 hours. Now you could keep adding in this process. So again, I could add 28 to my previous number of 56. So I could do 56 plus 28, and that's going to give me 84. But now, there is another way to do this, and that would be a way to write an equation. So, my purple number here, 28, represents my constant. Now, whatever my constant is, I can multiply by the variable x represented in hours. So x represents hours, and that number is going to change. Now, no matter what amount of hours this deer is traveling, can be multiplied by 28, and that's going to give me the value of y, the amount of miles. So if I take 28 and I multiply it by the number of hours, I can tell how many miles the deer goes, which is going to represent y. So let's take a look at 4 hours. So I could plug 4 into my equation. So I could have y will equal, well, I'm just going to write the equation. So I have 28 as my constant, multiplied by the amount of hours, 4, so I got 28, which is my constant, multiplied by 4, and when I do that, 28 times 4, I'm going to get y, the number of miles. And in that case, 28 times 4 is 112. Now I can continue this process all the way down. So 5 times 28 is going to give me 140 miles. Now remember, I'm multiplying my constant by the number of hours. So the constant is that this guy is going 28 miles per hour, meaning every hour he goes another 28 miles. So for every 6 hours this deer is traveling, he's going 28 miles in 6 hours. So 28 times 6, which is going to give me an answer of 28 times 6 is 168. And again, the same thing for 8. So I can do 8 times 28, and that's going to give me an answer of 224. And then 28 times 9 is going to give me the amount of miles of 254. So now your table is filled in. You've found your constant rate by taking y, the amount of miles, dividing it by the amount of hours to tell me how many miles the deer can go in 1 hour. And then we can tell using an equation, using the constant multiplied by an x. Oops, sorry about that. We got an update coming up. We'll cancel this. Sorry about that. So again, I can take my constant and multiply it by my x variable, and these numbers are variables because they can change depending on how many hours we want to calculate for the number of miles that the deers go. So you have a graph over here, so we have to label our graph, and I chose the bottom to represent the amount of hours, and my table goes up to 9, so I labeled my segments in units of 1, okay? And then we have to label the side of the graph, and what do you think that's going to be? That's right. It's going to be the amount of miles that the deers go. So we need to label miles over here. Now, how do you know what it's increasing by? Well, I can take 1 hour and figure out how many that was. So I knew that it was 28. So I can place 28 where it will meet 1 on my graph. And I can do the same for each one of these values. So I'm increasing by 28 each time on these lines. So just give me a moment to do that. Okay. Now, in order for us to tell if something is proportional from a graph, it needs to be a straight line and pass through the origin, which is right down here by 0. Okay? So what we want to do is start plotting our lines for our ordered pairs. So every hour he goes 28 miles. So I want to plot that line right here. So I can go every 1 hour he goes 28. And every 2 hours he goes 56. Three hours was 84. 4 hours was 112 miles. 5 hours was 140. 6 hours was 168. And what you're going to start to see here is a pattern, and it looks like this is going to be a straight line. So if I start at my origin, and I have a line, a straight line that passes through all of these points, I am going to find that I have a proportion. So when you're writing an equation, you want to take your constant, multiply it by whatever variable x is. So in this case, it was the number of hours, and that's going to give me y. So I rewrote the equation over here, and m is representing my y, which is miles, and x is representing hours. So I'm going to change x to h. To represent that I'm multiplying 28 miles by the number of hours I'm trying to find. So, a quick verbal description of this is a white-tailed deer travels at a rate of blank miles per hour. So, how many miles does he go in 1 hour? And I'm representing that here with my little hand right here. And then, how do we know it has proportionality? Well, the constant rate of 28 miles per hour, right? That's how fast he's going per hour. We have a straight line, and it does pass through the origin. And don't forget that your origin is located at the very start of your graph, right there. That's your origin, where 0 is. So it's got to pass through your origin. All right, moving on down. So the information that was given to us was in this verbal description. So the student council is selling t-shirts to raise awareness for local animal shelter. For each t-shirt they sell, they will donate $7. So, in my table up here, I can start to kind of fill this in. So, what do I know? I know that each t-shirt is $7. So, they basically want to know the total amount donated for 5 t-shirts. Well, 5 t-shirts is going to be $7 times X, which is 5, will give me $35. Now, why is it $35? Because each t-shirt costs $7. So, I have to multiply the number of t-shirts, X, by the constant rate of $7, because each one costs 7. So I have 7 plus 7 plus 7 plus 7 plus 7, which is 35, or 7 times 5, which is 35. So each time I can take my equation and plug in whatever X is. So it could be something like 7 times 10. And then again, I could do 7 times 15 because each x value is going to be changing. It is variable. Now every time you do this, you're going to get a brand new y. And I think that you guys get the point, so I won't waste any more of your time copying and pasting my equation. So, real quick, 7 times 10 is going to give me a total of $70. So now what I went ahead and did for you on your graph is I represented the number of t-shirts over on the graph over here with the increasing number of t-shirts. So it went up by 5 each time, so I labeled my graph here. So the total amount donated is going to need to be on your y-axis. So whatever the numbers you get after you're done multiplying your equations here, you can place over on your graph over here and find out if the line is straight and passes through the origin. So it will be proportional, right? If it is a straight line, right? If it passes through the origin. And if the ratio of y divided by x is 7. So basically your job is to fill in the rest of the table and plot the points on this table and draw a line through your points. Very similar to what we did up here. It's the same process. So looking down at the bottom of the second page, it says read each scenario below, determine if the situation is proportional or not. If it is proportional, then write an equation to represent it. Well, a restaurant charges $10 for a medium pizza and $1 for each topping. This is not a proportional situation because the rate can be changing, right? Because what happens if you do not get a medium pizza with a topping? So a medium pizza could be $10, and then I could get a second medium pizza for $11 because I got a topping on it. So it is not the same rate because the first pizza without a topping could be $10, and then the second pizza could be $11, and it just increased by 11. So that means I am not increasing by 10. I can be increasing by 10, or I could be increasing by 11, and that is not the same rate. Remember, rate means it's the same. The constant rate means it is the same increase. In this case, I could be increasing by 10, or I could be increasing by 11, in which I do not have a constant rate. All right. However, in some of these other ones, if you take a look at the equation here, y equals 10x plus 1 versus the rest of the equations I wrote down here, all right, there is no addition. It is just simply a unit rate multiplied by whatever x is. In this case, x is the number of people. So a restaurant has an all-you-can-eat buffet, and they charge $8.75 per person. So it is definitely going to be proportional because X is going to be the number of people, which can change. I don't know how many people are coming to this all-you-can-eat buffet, but I do know each person I bring is going to increase the cost by $8.75, where Y is going to represent the total cost. So for most of these, so for example, 3, 4, 5, and oh, look at that. They did 2 6s here. But that's going to be number 7. Here, I'll even write number 7 there so you guys know what number that is. All right, so we got 3, 4, 5, and 7. I'm sorry, and 6 are dealing with the total cost. So what we're trying to figure out is the total cost. So Y, we want to figure out, is the total cost. So number 5, it says a restaurant charges $1.50 for a fountain drink with free refills. Well, this is proportional because for every number of drinks I refill, the cost is still going to be $1.50. So no matter what X is, the constant rate for each one is $1.50, where X is the number of drinks purchased and Y is the total cost. So moving on to the next one. A restaurant has a build-your-own salad option. It is $3.80 per pound of salad. And I already told you that is proportional. You have to use the information provided in number 7 to fill in the blanks. And remember, the constant is going to be your amount, right, multiplied by X, which is the number of pounds of a salad. For number 6, a vehicle travels at a rate of 65 miles per hour. This is definitely proportional because it is going to be increasing 65 miles per hour, which is X. So where X is the number of hours and Y is the total miles traveled. In your summary, you can take any of the information from above. I always like to take stuff that is from the top here. Maybe just explain why it is proportional. So to tell me what features can tell me if my data set here is proportional or not. So remember, proportions need to be a straight line, and they need to pass through the origin, and they need to have a constant rate that is the same throughout the chart and the graph. All right, guys, that's going to be it for today. Everybody stay safe and take care.